Good morning, everyone. Welcome to the online education for English medium organized by the Education Department of Municipal Corporation of Greater Mumbai. So, we are going to be studying the topic study of sound for class 9th, right? And today we are going to be continuing with the topics of sonar and concepts relating to human ear. Okay. So my name is Vishal Chaudhary. I am from Kurar Village MPS English Secondary School. So let us first of all see what all topics we have been covering in this chapter. The various topics are sound waves, velocity, then human ear, audible sound, infrasonic sound, and ultrasound, right? So far we have studied about the definition of sound, properties of sound waves, longitudinal waves, then transverse wave, characteristics of sound waves. Then we have studied concepts relating to velocity of sound, variation in velocity of sound. Then we have also studied about the types of sound, that is audible sound, infrasound, and ultrasound. And then also about concepts relating to reflection of sound, echo, and reverberation. Let us briefly go through these concepts. Okay, so we had first seen the definition of sound. So sound is a form of energy which creates a sensation of hearing in our ears, right? So sound energy travels in the form of waves, and the medium is necessary for the propagation of sound waves. So as we have seen previously, as you can see here in the diagram, you can see that the speaker, which is the source of a sound, generates the sound waves, and the sound waves travel away from the source, which is the speaker, right? So air molecules are required for those sound waves to go through. So sound waves or sound energy is also called as material waves, right? Because they need a material to travel through. That can be a solid, liquid, or a gas. Sound waves give rise to a chain of compressions and rarefactions in the medium, right? As you can see here, compressions are regions of high pressure, whereas rarefactions are regions of low pressure. So if you can observe one of those particles there, which is highlighted with a red color, you can see the particle just happens to oscillate back and forth at its mean position, and thereby transmitting the sound energy, right, through the material. Then longitudinal waves. In a longitudinal wave, the particles of the medium oscillate about their mean positions in a direction parallel to the propagation of the wave. So as you can see here, the particle happens to oscillate back and forth, that is from left to right, and the wave also happens to move overall from the left hand side to the right hand side. That means the direction of oscillation means direction of vibration, and the direction of motion of the wave, right? Such a wave is said to be a longitudinal wave. Okay, then. So sound waves are a form of a longitudinal wave. So a sound wave can be shown in the form of a graph. At any moment during the propagation of a sound wave, we can find alternate bands of compression and rarefaction of the medium, that is bands of high and low density. Okay, so as you can see here in the diagram, the waves are shown in the form of alternate bands of compressions and rarefactions, right, which originate from the loudspeaker and move away from the source, that is the loudspeaker. They can also be shown in the form of vertical lines, right, where compressions are shown by vertical lines which are very close to each other, and rarefactions are shown where lines move apart from each other. Okay, then we studied about velocity of sound. So the distance covered by the point on a wave in unit time is a velocity of the sound wave. We know velocity equals to distance upon time. Now, any point on the sound wave covers a distance equal to lambda, which is a wavelength, in time t. Thus, the velocity is given by v equals to nu into lambda, where nu is the frequency, lambda is the wavelength, right? And we also know that 1 by t, which is 1 by time period, equals to frequency. Hence, we can write velocity is equal to wavelength upon time period, that is v equals to lambda by t. Okay, so we had seen the variation in velocity of the sounds, right? So first is what? Variation with temperature. So we know that velocity of sound is directly proportional to the square root of the temperature. Then variation with density is velocity of sound is inversely proportional to the square root of the density, and with molecular weight, velocity of sound is inversely proportional to the square root of the molecular weight, right? Then in the second session, we had studied about the types of sound, right? So the types of sound are classified based on the ability of humans to hear those sound or not. Okay, so the first category is the audible sound. So audible sounds have a frequency range of 20 hertz to 20,000 hertz, right? That means any object vibrating at a rate of 20 times per second to about 20,000 times per second. So such sound generated will be audible to us humans. Then the other is the infrasound. So infrasound is having a frequency less than 20 hertz, means any object which happens to vibrate less than 20 times per second will generate an infrasound. And infrasounds are not audible, as humans cannot listen to infrasounds. And the last is the ultrasound. The ultrasound have a frequency higher than 20,000 hertz, means any object vibrating at a speed of more than 20,000 times per second will generate a ultrasonic sound waves, right? Again, these ultrasounds, they cannot be heard by humans. Okay, the next is what, let us go into detail about the three types of sound. The first is what, audible sound. The limits of hearing of the human ear are 20 hertz to 20,000 hertz. The human ear can hear sound frequencies in this range. These sounds are called as audible sounds. Human ears cannot hear frequencies lower than 20 hertz and higher than 20,000 hertz. Then, infrasound. Sound waves with frequencies smaller than 20 hertz are called infrasound. The sound produced by a pendulum and the sounds generated by the vibration of the Earth's crust just before an earthquake are the examples of infrasound. Okay. Then next is ultrasound. Sound waves with frequency greater than 20,000 hertz are called as ultrasound. Dogs, mouse, bats, dolphins, etc. have a special ability to hear ultrasonic sounds. They can sense some noise which are inaudible to us humans. Children under 5 years of age and some creatures and insects can hear frequencies up to 25 kilohertz, that is 25,000 hertz. Right. Next, we had also studied about the concept of reflection of sound. So we know that sound waves, just like light waves, also obey the laws of reflection, which can be seen by this above activity. Right. In this case, what we have, we first of all have a source of sound, which is a stopwatch, which is a ticking, which will create a ticking sound. Now, in front of that stopwatch, we have a hard plywood placed and a partition of soft wood, right? And we have placed two cardboard tubes which help to channel the sound waves through, right? Now, if you sit on the other side and try to listen to the sound of the ticking stopwatch, you can hear, right? In this case, you can see the incident rays make an angle, incident sound waves make an angle I with the soft board, right? And we know, according to laws of reflection, that angle of incidence is equal to angle of reflection, right? This proves that the sound also does get reflected and it also obeys the laws of reflection. Okay. Then now, one of the important aspects or important properties relating to the reflection of sound is echo. Okay, so an echo is a repetition of the original sound because of reflection from some surface. Okay, so at 22 degrees Celsius, the velocity of sound in air is 344 meters per second. Our brain retains this sound for 0.1 seconds. Now this means that whenever any specific frequency of a sound enters into your ears, right, our brain registers it as a sound, right? Our brain has a special ability because of which you cannot hear the same sound frequency within a time interval of 0.1 seconds. Means if you have to listen to the same sound frequency, it must come after a time interval of 0.1 seconds. If it comes before 0.1 seconds, you cannot hear it. Okay, this is what is called as a retention of the sound. Thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 seconds after starting from the source to get reflected and come back to us. That means if you look at this diagram here, the animation here, you can see the person is producing the sound. right, which travels towards the object, which is the wall, and gets reflected and travels back, which the person hears as an echo. So the total time required for the sound wave to travel from the person up to the wall and back again should be more than 0.1 seconds. If it comes before 0.1 seconds, our brain cannot listen to that sound. So it should come after an interval of 0.1 seconds, right? So let us see how to calculate the minimum distance that must be present between the person creating the sound, means the observer, and the obstacle, which is the wall. Let us see. So we can determine the minimum distance between the source and the reflecting surface as follows. So we know that speed equals to distance upon time. Therefore, we can write distance is equal to speed multiplied by time, right? So we know that the speed of sound is 344 meters per second, and the minimum time interval for the sound waves to get reflected and come back should be 0.1 seconds. So we get a distance of 34.4 meters. So thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meters. Why is it so? Because this distance 34.4 meters is a total distance, that is a back and forth motion. Total distance traveled by sound, that is from the source of the sound up to the reflecting surface and then back to the listener. So that is a double the distance. That is why we take half of 34.4. Okay. The next concept that we have studied, which is an undesirable property of a reflection of sound, is called as reverberation. Right. Now let us see. Now sound waves get reflected from the walls and roof of a room multiple times. Repeated reflections of sound waves from the walls combine to build up what seems like a continuous sound. This causes single sound to be not heard once but continuously, which creates a large amount of disturbance. Okay, and this is called as a reverberation. Okay, the time between successive reflections of a particular sound wave reaching us becomes smaller and smaller, and the reflected sound gets mixed up to produce a continuous sound, increasing the loudness which cannot be heard clearly. So, if you observe this diagram, what do we have? We have a speaker who is sitting or standing on the stage, and you can see there is a listener standing on the right hand side, and the place can be an auditorium, right? So when the speaker is talking or creating a sound, the sound waves travel in all the possible directions, right? So the first sound that reaches the listener is a direct straight sound wave, right? But because the sound travels in all possible directions, sound also travels upwards, then behind the speaker, then just above the listener, and gets reflected multiple times from the different surfaces which are present in the room or the auditorium, right? So what happens because of this is the sound waves happen to travel different distances in all of these cases. As they are traveling different distances, the sound wave will take different amount of time to reach the listener, right? Hence the sound ends up in the form of a continuous sound of increasing loudness, which is called as reverberation. Okay, then how to reduce reverberation? Some auditoriums, public halls, or buildings are considered acoustically poor because of the formation of reverberation. To reduce reverberation, the roof and walls of auditoriums are generally covered with some sound absorbing materials such as compressed fiber boards, rough plaster, or curtains, or you may have several designs and different shapes on the walls, right? In short, you will have to coat and cover the walls and the different features of the auditorium with sound absorbing materials, means materials which are bad reflectors of sound. Okay, then even the materials of the seats is chosen such that it absorbs the sound waves to the desired extent. Okay, now let us move into the new topic that we are studying today, that is relating to sonar. Let us see what is sonar. A sonar is a short form for sound navigation and ranging. It is used to determine the direction, distance, and speed of an underwater object with the help of ultrasonic sound waves. Right. So sonar has a transmitter and receiver which are fitted on ships or boats. Now, if you look at the diagram here, now you can see there is a ship that is floating on the surface of the ocean or maybe the sea. Now the ship has one transmitter fitted which will transmit ultrasonic sound waves towards the seafloor, towards the bottom. And there is one more receiver which is fitted on the ship right, which will absorb and which will collect the reflected sound waves coming from the bottom of the sea. So what happens is the transmitter will send these sound waves, that is ultrasonic sound waves, which is called the transmitted pulse, through the water towards the ocean floor. Then the sound waves will strike on the ocean floor on the different surfaces or different objects on the sea floor, and they will get reflected. This reflected pulse will be received by the receiver, and then the signal is sent to a computer which will calculate the time required for the sound waves to come back and then create a picture of the uh, sea floor and whatever features are there on the sea floor, which will be displayed on a computer screen, right? And then you can find out whatever is present on the sea floor. Okay, let us see how it works. The transmitter produces and transmits ultrasonic sound waves. These waves travel through the water, strike underwater objects, and get reflected by them. The reflected waves are received by the receiver on the ship, right? So these underwater objects, they can be anything. There can be a shoal of fish, or there can be a submarine, or there can be a sunken ship on the bottom of the floor, or you can also observe deep locations, right? You can it can be used to determine the depth of the sea at a given location, right? There are various applications of sonar. Then let us see. The receiver converts the ultrasonic sound into electrical signals, and they are properly interpreted by a computer. The time difference between the transmission and reception is noted. This time and velocity of the sound in water give the distance from the ship of the object which reflects the waves. So you can find out the actual distance between the ship and the object which is reflecting the sound waves. In this case, as you can see the diagram, right? The fisherman can use on the fisherman can see, and by using the sonar he can determine the depth at which the fish are present, and he can place his fishing nets accordingly. Okay, so sonar is used to determine the depth of the sea and to search underwater hills, valleys, submarines, icebergs, sunken ships, etc. Right? Now the other concept relating to the reflection of sound is called as sonography. The sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. This is useful in finding out the cause of swelling, infections, pain, etc. The condition of the heart, the state of the heart after a heart attack, as well as the growth of the fetus inside the womb of a pregnant woman are studied using sonography. Now, nowadays, sonography is used by the doctors as a method to detect the problems or method to find out any diseases which is there in the body. Right? It is a non-invasive technique. That means there is no such operation required. There is no need to give any medicines. There is no need to give any anesthesia. Right? The patient is present and he is conscious when the procedure is done. And this can be completed within 15 to 20 minutes. Okay, and it is a non-invasive. There is no need for the patient to get admitted also. Okay, let us see. This technique makes use of a probe and a gel, and the gel is used to make proper contact between the skin and the probe so that the full capacity of the ultrasound can be utilized. Now here you can see in the middle, the diagram shows the probe which is used, right? So it is a handheld device which has what a transmitter for transmitting the ultrasonic sound waves, right? And also receiving the sound waves. And it is connected to the computer device which generates the images as you can see on the display. So the technician, the sonography technician does know how to obtain the images and what is exactly visible, right? So the sonography technician is trained to identify the position of the different organs inside the human body, and then he can generate the report which can be shown to the doctor. Okay, then let us see. The gel is applied to the skin outside the internal organ to be studied. So for example, if you are having some stomach pain in your abdomen, then the doctor will ask you to get a sonography done. So when you visit the sonography place, the person, the technician who is conducting the sonography will first apply a gel on your stomach, right? Now the gel is there so that the ultrasonic sound waves coming from the probe, right, will be transmitted through your skin into your body, right? So the gel is applied to the skin outside the internal organ to be studied. high frequency ultrasonic sound is transmitted inside the body with the help of the probe. So what happens is the ultrasonic sound waves, they travel inside the body, and inside our body we have different organs. All the organs have different densities, right? So sound travels differently in all of these organs, right? And then what happens is the sound also gets reflected and comes back towards the probe, right? And the probe will capture. Let us see. The sound reflected from the internal organ is again collected by the probe and fed to a computer which generates the images of the internal organ, as you can see here in the picture. As this method is painless, it is increasingly used in medical practice for correct diagnosis. Diagnosis means to find out what is the exact problem. Okay, so they can be used to detect kidney stones or gallbladder stones or any other problem which is there in the abdomen. Okay, so as you can see, it is a painless method. Means there is if the patient experiences no pain because of the device. The person may have pain because of the disease, but because of this machine, because of the sonography machine, the person does not experience any pain. It is a painless method. Okay, then now let us move into the very important part of the chapter, that is relating to the human ear. Here we are going to study about the various parts of the human ear and how exactly the human ear works. Okay, so let us see. The ear is an important organ of the human body. It is a very important, one of the important sensory organs, right? We hear the sounds because of our ear. When sound waves fall on the eardrum, it vibrates, and these vibrations are converted into electrical signals which travel to the brain through the nerves, right? So you can see the diagram of the human ear, how exactly the structure of the inner ear is present, right? So you can see here the inner ear, the ear is divided into three main parts, right? The first is the outer ear, which you can see. The second is the middle ear, right? And the third is the inner ear. Okay, so we will see it in detail. Let us see. The human ear can be divided into three parts. The first one is the outer ear, the second is the middle ear, and the third one is the inner ear, right? So as you can see here in the diagram, this is the diagram from the textbook, right? So in the outer ear, you have the pinna, which is the structure which is seen outside. Then you have the auditory canal and the tympanic cavity. At the end of the tympanic cavity, you have the eardrum. Just behind the eardrum, you have a chain of three bones, right? And then these three bones, they are connected to a spiral device which is called as a cochlea, right? We will see about that in detail. Now let us see the various parts of the human ear. We will see first about the outer ear or the pinna. The outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape helps to connect and pass the sounds into the middle ear, right? Now, if you look at the diagram, the inner ear has a structure, the outer ear has a structure, right, which helps to collect and send the various sound waves inside the ear canal, and from where the sound waves will reach onto the eardrum, right? So the outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape helps to collect and pass sounds into the middle ear. Then the middle ear is there. Now there is a thin membrane in the cavity of the middle ear called as the eardrum. Now when a compression in the sound wave reaches the eardrum, the pressure outside it increases and it gets pushed inwards. Now you must remember, sound waves travels in the form of longitudinal waves, right, which are a series of compressions and rarefactions. So when the compression reaches the eardrum, the compression is a region of high pressure, right? So what happens is the eardrum gets pushed inwards because of the high pressure, right? The sound waves get pushed inwards, and the opposite happens when a rarefaction reaches there, right? So the pressure outside the decreases and the membrane gets pulled outwards. So when the compressions and rarefactions reaches the eardrum, which is the membrane, the eardrum starts vibrating with the same frequency of the sound wave. Means when the compression reaches, the eardrum is pushed inwards. When the rarefaction reaches the eardrum is pulled outwards with the same frequency as the sound. Okay, so thus sound waves cause the vibrations of the membrane. Okay, as you can see here in this case, see the sound waves are collected by the outer ear and they are transmitted into the auditory canal. From there, they reach onto the eardrum, where the eardrum also starts vibrating with the same frequency of the sound wave. Now, if you look at the diagram carefully, just behind the eardrum, we have your inner ear, where you have the set of three bones. Can you see the three bones? The small three bones, which also start vibrating with the eardrum. And these vibrations are transmitted into the spiral structure, as you can see there. Right? Let us talk about the inner ear now. The auditory nerve connects the inner ear to the brain. The inner ear has a structure resembling the shell of a snail. It is called as a cochlea. Right, as you can look at the diagram here, you can see the is the inner ear, which is the spiral shaped structure there. Right. So what happens is, as a sound enters the outer ear through the pinna, it reaches the middle ear, where you have the eardrum. Right. Now the eardrum starts vibrating with the same sound frequency of the sound, and then these vibrations are transferred onto the set of three bones. Right. These three bones then transfer these vibrations onto the cochlea. Right. The cochlea is an important part of the inner ear, where the sound, the vibrational energy is converted into electrical signals. Right. And which are sent to the brain. Okay. Let us see. The auditory nerve connects the inner ear to the brain. The inner ear has a structure resembling the shell of a snail, and it is called as a cochlea. The cochlea receives the vibration coming from the membrane, which is the eardrum, and converts them into electrical signals, which are sent to the brain through the auditory nerve. And the brain then analyzes these signals as sound, and thus we can perceive, right, and hear the sound. Got it? That is how the ear works. Okay. So let us talk about some questions that I will expect students to be doing. Right. First one is, what is sonar? You can write there, sonar is a short form for sound navigation and ranging, and it is used to determine the presence of underwater objects and also to find out the depth of the sea at various locations. Then state the applications of sonar. You can say sonar is used for measuring the depth of the sea at various locations. Then it is also used to find out the presence of fish and to find out the location of the fish by fishermen. Right. It is also used to find out the presence of underwater submarines. It is also used to find out the position of sunken ships. Right. Then, how is sonography technology useful in medical diagnosis? So you can write there, sonography technology is a painless method. It can be used to find out the presence of any abnormalities that is present in the body. Right. Then, fourth is, draw neat level structure of the human ear. Right. So you can draw that structure which is here from the textbook, figure 12.6. Right. And then next question is, explain the working of the human ear. Right. So for explanation of working of the human ear, you can explain the working of the outer ear pinna, then about the middle ear, and then about the inner ear. Right. So this is how we have concluded the chapter. Right. In the next class, that is tomorrow, we will be revising the whole chapter again, and then we will be discussing all the numerical problems that we have in this chapter. Right. So before we conclude the class for today, let us once again revise whatever topics that we have studied today. Right. So in today's class, we have studied about the concepts of sonar, then about sonography, right, and about the human ear. Right? Let us revise it again. Well, let us start from sonar. Now, sonar is a short form for sound navigation and ranging. It is used to determine the direction, distance, and speed of an underwater object with the help of ultrasonic sound waves. Now, sonar has a transmitter and receiver which are fitted on ships or boats. Right. So, as you can see here in the diagram, right, you may need to draw this diagram when you are writing the explanation for sonar. Okay. So, this is there in the textbook. So, you can see the ship is there floating on the sea, and you have one transmitter and one receiver which is fitted on the ship. So, what the transmitter does, it transmits the ultrasonic sound waves which gets reflected from the bottom of the sea and they are reflected and received by the receiver. Then this is connected to a computer which will know the exact time when the transmitter sent out the waves and when the waves are exactly received. And knowing the time interval, it can calculate and obtain images of the ocean floor. Right. Now, the transmitter produces and transmits ultrasonic sound waves. These waves travel through the water, strike underwater objects, and get reflected by them. The reflected waves are received by the receiver on the ship. Okay, so when these are received, the receiver is connected to a computer which can generate the different images of objects which are present under the water, that is towards the ocean floor. So there may be images obtained of the sea floor where you might have various features on the sea floor, presence of any sunken shapes or any other presence of underwater mountains, right? So these images can be obtained. Then the receiver converts the ultrasonic sound into electrical signals, and these signals are properly interpreted. The time difference between the transmission and reception is noted, that is noted by the machine, the computer. The time and velocity of sound in water give the distance from the ship of the object which reflects the waves. So sonar is used to determine the depth of the sea and to search for underwater hills, valleys, submarines, icebergs, and sunken ships. As you can see in this diagram, the fisherman can also use the sonar device to find out the presence of fish which are swimming in the water. Right. So when a fisherman is in the boat and if he is using a sonar device, right, the device can be used to spot the shoals of fish. Shoal, what is a shoal? When you have multiple number of fish, fish never swim alone, right? Fish swims in shoals. There can be hundreds of fish in a shoal together, right? So this can be seen in the sonar device, and accordingly the fisherman can place the nets at a correct depth inside the water. Now, with the next thing we studied today was sonography. A sonography technology uses ultrasonic sound waves to generate images of the internal organs of the human body. This is useful in finding out the cause of swelling, infections, or pain. This is very commonly carried out in presence of kidney stones or presence of gallbladder stones, right, or any other abnormality within the abdomen. Okay, then the condition of the heart of the heart after heart attack, as well as growth of fetus inside the womb of a pregnant woman are studied using sonography. Now you might be aware that the duration of pregnancy in humans is about 9 months, right? So once the baby is conceived, up to 9 months, the pregnant woman is made to undergo sonography procedures, right? During this, what happens is once every 2 or 3 months, the sonography checkup is made, and with the help of sonography, it is checked whether the fetus means the baby inside the pregnant woman, whether if it is growing properly, if there is any abnormality or any other problems are there, they're just regularly checked up. Okay. Then next is what? Let us see how it exactly works. This technique makes use of a probe and a gel. The gel is used to make proper contact between the skin and the probe so that the full capacity of the ultrasound can be utilized. Means whatever part of the body where you need to conduct sonography, just above that part on the skin, this gel is applied, and then that probe is placed and just moved around by the technician. The technician will move it with his hand so that the sound waves reach the different parts of the body, right? So these sound waves travel inside the body, they strike the various organs and come back, which are received again by the probe. So the probe has both transmitter as well as receiver, which will do both the jobs. Okay, and then that probe is connected to a computer device and which will generate the images on the screen, right? And the technician does know what to expect, means what kind of images are obtained when you see a normal person, what kind of images are obtained when there is a problem inside, right? So the technician is just like a doctor, so he can find out and give you a report which can be given to the doctor, and then the doctor will suggest the correct path or correct mode of your treatment. Okay, let us study further. The gel is applied to the skin outside the internal organ to be studied, just I told you. High frequency ultrasound is transmitted inside the body with the help of the probe. The sound reflected from the internal organ is again collected by the probe and fed to a computer which generates the images of the internal organs. As this method is painless, it is increasingly used in medical practice for correct diagnosis, right? So sonography is one of the first diagnosis methods which are obtained, which are done generally. So whenever you fall sick or whenever there is any problem, the doctor will suggest you to get a blood test done first of all, right? And from that blood reports, he may give you a medicine. Even still, if you have a problem, then the doctor will ask you to get a sonography done, and that will get you a lot of information if there is any problem. Okay. Then the next part we studied was about the human ear. So we know the human ear is an important organ of the human body. It is related to one of our very important senses of hearing. Okay. We hear sounds because of our ear. When sound waves fall on the eardrum, it vibrates. These vibrations are converted into electrical signals which travel to the brain through the nerves. As you can see in this diagram, the various parts that we have studied, right? So we will make use of this diagram again. So the human ear can be divided to three parts: the outer ear, the middle ear, and the inner ear. Let us study that. The outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape helps to collect and pass sounds into the middle ear. So the outer part of the ear you can touch is called as a pinna. Its only function is to collect the sound waves coming from different directions and channel them into the middle ear, right, which is the ear canal. In the middle ear, there is a thin membrane in the cavity of the middle ear called the eardrum. When a compression in the sound wave reaches the eardrum, the pressure outside it increases because compressions are regions of high pressure, right? So because the pressure increases, it will push the eardrum inside and it gets pushed inwards. Fine. The opposite happens when a rarefaction reaches there. So rarefaction is a region of low pressure. So low pressure will pull onto the eardrum, right, and it will go out, right? So the pressure outside decreases and the membrane gets pulled outwards. Thus, sound waves cause vibrations of the membrane. So when a sound wave of a given frequency reaches the ear, I mean the eardrum also starts vibrating with the same frequency of the sound. Okay, as you can see here, look at the sound waves, right, which come inside the external auditory canal, then it reaches onto the eardrum. As you can see, the eardrum starts vibrating and then it sets into motion, means it also starts vibrating the three set of bones which are connected to the cochlea. If you go on to the first diagram, yes, you can see it here quite clearly, right? You can see the white colored eardrum which is there, right? And just behind the eardrum you have the set of the three bones, right, which are connected to each other. And when the eardrum vibrates, the vibration is passed on to these bones and which is connected to the cochlea, which you can see, which is a spiral structure, right? Okay, and to this what we have is the auditory nerve, which is the yellow colored part which is connected to this, right, and from where the electrical signals are then sent onto the brain, right? Let us study further. The auditory nerve, let us talk about the inner ear. The auditory nerve connects the inner ear to the brain, and the inner ear has a structure resembling the shell of a snail, and it is called as a cochlea. The cochlea receives the vibrations coming from the membrane and converts them into electrical signals, which are sent to the brain through the auditory nerve. And the brain then analyzes these signals, right? So, if you observe this diagram here, you can see that the eardrum is a very delicate structure. So you are not supposed to insert any objects inside the ear. Why? Because if the eardrum happens to get damaged, what will happen? The eardrum will not be able to catch the vibrations. It will not be able to vibrate with the sound, right? And hence you lose the sensation of hearing. Means that your ears will stop working if the eardrum gets damaged, right? So you need to be very careful. You are not supposed to insert anything into your ear, right? So that is it for today. So in the class tomorrow, we will be revising the whole chapter again, and also we are going to be discussing and solving the numerical problems from this chapter, right? So now let us go back and see if we have any doubts here. So any students, if you have any doubt, please you can raise your hands and ask the question. Come on, students. Yes, if you happen to have any doubts, You can please ask me. Okay, we can see there are no such doubts here, no questions from the students' ends. Yes. Hello, madam.
Yes, sir.
Yes, madam. They don't seem to be. They don't have any doubts, I think.
Okay, okay, sir.
Yes.
Okay.
So we
Thank you
have
so much,
completed
sir.
the class for today. Yes,
Yes,
madam.
yes.
Yes.
Yes,
Okay.
thank you, sir.
Yes, madam.